Hello everyone, welcome to Mathematics Step by Step. I am Ying. So today we'll learn to determine the effect of data changes on dispersion based on the value of measure of dispersion and also the graphical representation. Okay, so what is the effect of data changes on dispersion? So these are the few kinds of data changes. So first one, each data is added or subtracted by a constant uniformly. Second case, each data is multiplied or divided by a constant uniformly. Then the third case, the existence of outliers or extreme values in the set of data. And lastly, certain values are removed from the set of data or added into the set of data. Okay, so coming next, we'll learn a lot of different examples on all these. Okay, so do not worry. So what are the effects on the measure of dispersion when each data is changed by adding or subtracting a constant? So look at this set of data, 5, 8, 3, 4, 1. If each value of the set of data is added by 5, so now the set of data becomes 10, 13, 8, 9, 6, right? Okay. What will happen to the measures of dispersion such as range, interquartile range, variance and standard deviation for the new set of data? So we will figure out what is the effect to all these measures of dispersion. Okay, so go back, you guys will do this mind stimulation tree. Okay, so you guys will find a few friends and have this discussion together. Okay, so this is the conclusion made from the mind stimulation tree. Okay, so there will be no changes to the measure of dispersion when each value of a set of data is added or subtracted by a constant. So let's look at this example again. Initially, for the set of data, before each data is added by 5, the range is 8 minus 1, which is 7. Okay, 8 is the greatest value, 1 is the smallest value. Then now, after added 5 to each data, the range is 13 minus 6, so equals to 7 also. So after you work this out, right, you'll find that the range, interquartile range, variance and standard deviation for the new set of data remain the same. Okay, so now what are the effects on the measure of dispersion when each value of a set of data is multiplied or divided by constant? Just now we have learned for the case of addition and subtraction. So now what is the effect on the measure of dispersion when each data in the set is multiplied or divided by a constant? So let's see. This is the original set of data. Then after each data is multiplied by 2, we get the new set of data here, 10, 16, 6, 8, and 2. So now we want to see what are the effects to the range, interquartile range, variance, and standard deviation. Okay, so again, you guys will find a few friends and have this discussion together. So this is the conclusion made. So after your discussion, you can check here to see whether your discussion is going in the right direction. So when each value of a set of data is multiplied by a constant k, the new range will be k times the original range. New interquartile range will be k times the original interquartile range. New standard deviation will be k times the original standard deviation. Then the new variance will be k squared times the original variance. Okay, this is very important, so take note. Okay, then when each value of a set of data is divided by a constant, then the new range is the original range divided by k. New interquartile range will be original interquartile range divided by k. New standard deviation will be original standard deviation divided by k. New variance will be original variance divided by k squared. So again, please take note. Okay, so now what are the effects on the measures of dispersion when an outlier is added or removed from the set of data? So first of all, let's look at the range. The range will change dramatically when an outlier is added or removed. Then for the case of interquartile range, it is less affected when an outlier is added or removed. from the set of data, okay? Then variance and standard deviation will increase significantly when an outlier is added into the set of data, okay? So if the difference between the new value of the data and the mean is small, then the new standard deviation will be smaller, so meaning is less dispersed, okay? Meaning the set of data is less scattered. Then if the difference between the value that is removed and the mean is small, then the new standard deviation will be larger, so meaning that this set of data is more dispersed now, okay? Less concentrated, okay? So how do you determine the effect of data changes on dispersion based on graphical representation? So the effect of data changes can be graphically displayed by using a dot plot, stem and leaf plot, or box plot, okay? We have learned about these three graphical representation previously. I hope you still remember. So first of all, A, we can see that both of these are dot plots, okay? The data is changed uniformly by adding or subtracting a constant. So let's see, the minimum value in this case is 8, then now becomes 10. Then this 3 data initially is 9, then now becomes 11. Then here the maximum value, we can see that now is added by 2, becomes 17, okay? So you guys will check all these and you will find out everything is plus 2 now in this case, okay? So we can see that each data is added by 2. So it is found that the whole dot plot is shifted to the right by 2 units, where the dispersion remains unchanged. You see the original score range is 15 minus 8, which is 7. Then now the range is 17 minus 10, also 7, okay? So the range remains the same. And also for the other measure of dispersion will remain unchanged, okay? Then, now this is the original set of data. This is the set of data after multiplied by 2 for each data in the set. So previously 1 now becomes 2. Previously 2 now becomes 4, okay? Everything times 2. So we can see that the original range is 5 minus 1 equals to 4. But now the range is 10 minus 2 equals to 8, okay? The range is times 2 now, okay? K times the original range, and K is the constant multiplied to each data in the set. So what is the conclusion that we can make? When each value of a set of data is multiplied by a constant K, the measure of dispersion will change, okay? As what we have seen in the green color box just now, okay? So later you can refer back to previous page on that. So now let's look at the third case. So this is the original set of data. Then now we can see there's an outlier here. Previously there's no outlier, okay? So the range previously is 5 minus 1 equals to 4. But then now the range is 9 minus 1 equals to 8, okay? So the range becomes larger compared to the original set of data when an outlier is added, because now the set of data is having a wider range. So what is the conclusion that we can make? The measure of dispersion of the new set of data become larger compared to the measures of dispersion of the original set of data when an outlier is added, okay? So now let's go through this example 13 together. Given a set of data 4, 6, 7, 7, 9, 11, 12, 12, calculate the standard deviation of the set of data. So again, we'll find the mean first. We'll add up all these, then divide by 8, because now there are 8 of them, okay? So the mean 8.5. So now we'll calculate the standard deviation and we'll apply the formula for standard deviation, okay? So we sum up the square of each of them, then divide by 8 and minus the mean square, okay? Then square root of it is the standard deviation, okay? So 2.784. Then now, calculate the new standard deviation when A, 4 is removed. So now, when 4 is removed, the set of data becomes 6, 7, 7, 9, 11, 12, 12, okay? So again, we'll find the mean first. We add them up, then now left with 7 of them. So the new mean is 9.143. Then again, we apply the formula for standard deviation. We'll find the standard deviation now is less compared to in A, okay? Because now we have removed the minimum value in the set. So now the set of data is less dispersed, okay? So we can see that the standard deviation is smaller. Then B, calculate the new standard deviation when 7 is added. So when 7 is added, now the set of data becomes 4, 6, 7, 7, 7, 9, 11, 12, 12, okay? So again, we'll add them up. Then now we'll divide by 9 because we have added a 7 here. There are 9 of them in this set. So the mean is 8.333. Again, we'll apply the formula for standard deviation, and we found the standard deviation equals to 2.668, okay? So we can see that the value 7 is close to the mean 8.333. So that's why the new standard deviation is smaller, okay? Let's see for the case of part C, 18 is added. So in this case, now the set of data becomes 4, 6, 7, 7, 9, 11, 12, 12, then 18, okay? So now again, there are 9 of them. We'll sum them up. We get the mean 9.556, and we apply the formula for standard deviation, and we found that the new standard deviation is 3.974, which is greater, okay? It becomes larger because you can see that 18 is quite far from the mean 9.556. So when it is added into the set of data, we will get a larger standard deviation, okay? So now we have reached the homework. Go back, you guys will do this self-practice 8.2D because practice makes perfect, okay? So that all the knowledge that we learned today belongs to you. Again, if you are struggling, you are having a lot of difficulty in completing all this homework, I have prepared an online course for you guys, okay? It is a step-by-step guideline in helping you guys to complete all this homework at home, including the comprehensive practice at the back of each chapter, okay? So coming next, we'll learn to compare and interpret 2 or more sets of ungrouped data based on the appropriate measure of dispersion, okay? So do not forget to subscribe to my YouTube channel so that you do not miss out any of my upcoming videos, okay? I will see you in the next video. Bye bye.